Yes, welcome yet again, students. Today we are going to learn how to write a chemical formula when given the chemical name of a chemical substance, and vice versa, how to name a chemical substance given the chemical formula. Thank you. You're most welcome. To start with, given the chemical name of the chemical substance, what do you consider to come up with the chemical formula of the particular chemical substance whose name has been given? For example, sodium chloride. Sodium chloride, from the sound of the word, has sodium and a chloride. Of course, this chloride is a radical. A chemical substance can be a combination of uh, different atoms of elements, or combination of atoms of elements with radicals. Of course, radicals are also made of atoms, but they behave as if they are only one atom. That's why they have single valency. The first step you take is, given the name, for example, sodium chloride, in words, you look at the atoms present in this particular chemical substance. In sodium chloride, we have sodium and a chloride. Well, of course, next is to look at the symbols for the atoms that are present, whether or the radical that is present and the atom. For this particular case, we have sodium atom and a chloride, which is a radical. Sodium is written as capital N and then a small a, which must cover at least half of the capital N. That's a correct symbol for sodium atom. Then a chloride is written as Cl negative, but however, when it is in a substance, the negative is not written. So we just simply write the chlorine atom. Okay? So we ignore the negative. For this we ignore the charge. This applies to all the radicals. Okay? While they're in the compound, once we are deriving the formula, we ignore the charge. We only use the charge as an idea to know its valence. Of course, after writing now down the atoms present in the particular chemical substance, what next is to see what is the valency of each and every atom that is present. For example, we now have sodium and chlorine atoms. If you look at sodium, sodium is in group 1, and of course that becomes its valence. The combining power is 1. Yeah, because it has all the group 1 elements have 1 electron in the outermost energy level that it uses to combine with others. So the combining power, which is called the valency, is 1. For chloride, it is written as Cl minus, that negative. It has a charge of 1 as a radical. The charge becomes its valency. Its combining power is the number of charge on it, and the charge is 1. So chloride has valency 1. Okay, you now interchange these valencies. The valency of chlorine, the chloride comes to as a subscript for sodium. Then the one of sodium is transferred as a subscript for the chloride. That's why it is written as NaCl. Another example, if we have potassium sulfate, potassium sulfate. Of course, in potassium sulfate, we're having potassium, which is capital K, and a sulfate, which is a radical. Sulfate is written as SO4, 2 negative. The charge, the number of the charge becomes its valency, because that's its combining power. Now, potassium is also in group 1, meaning it has 1 electron in the outermost energy level. When its structure is drawn, you'll see 1 electron, or if you write the electron configuration, 1 electron in the outermost energy level. And of course, that 1 electron is the one that is exposed and can be used to combine with the other atoms, and that's what it uses to combine. And that power of combination, which is called the valence. And that's why we say the valence of potassium is 1. Sulfate, being a radical, has valency of 2. So now you make sure radicals which are polyatomic, meaning having more than one atom, more than one atom, will have to be put into bracket. Like the sulfate has sulfur and oxygen, but it is as a sulfate, which is a radical. You have to put it into bracket. Thank you.